Gonna be solving Cambridge O-Levels Chemistry Paper 1 Multiple Choice October-November 2025 Paper 12. Separate samples of water and air each have a volume of 30 cm cube at room temperature and pressure. The pressure applied to the both samples is increased by the same amount at room temperature, which row describes the volumes at the increased pressure. Firstly, we know that water cannot be compressed even if you've increased the pressure, so it's going to remain 30, but we know that volume of air, since it's a gas, it's going to decrease, so it's going to be 30. It's going to become 3 from 30, because you know that the particles in liquid are already quite close together, so even if you apply pressure from above, it can't get further compressed, whereas the particles in a gas, they're far apart, so if you apply pressure, they can move closer together. Why does a balloon full of helium gas become small as the temperature changes from 30 degrees to 10 degrees? That's going to happen because the particles are going to move closer. Their kinetic energy reduces, right? And the pressure inside the balloon is also going to reduce. The gas particles move more slowly, so reducing the pressure. That makes sense. So that's the answer. But I'm going to read other options and eliminate. The gas condenses to a liquid? No. The gas particles become smaller. The particles never change size. Water particles in solid, liquid, gas are going to remain the same in all three states. The size of the particle never changes. The gas particles refuse through the balloon and escape. No, you're reducing their temperature. You're not making the particles escape. So that's nonsense. Atom X has an atomic number of 19. That means it has 19 protons and 19 electrons. And a nucleon number of 42. That means it has how many neutrons? Neutrons are atomic number minus the nucleon number, which is going to be 42 minus 19. So this gives us 23. Atom Y has an atomic number of 20 and a nuclear number of 40. So over here, the number of neutrons are going to be 40 minus 20, which is equals to 20. Which statement is correct? Atom X contains two more electrons than atom Y. No, the electron difference between X and Y is of 1 because 19 and 20. Atom X contains 3 more neutrons than atom Y. Yeah, that's correct because it has 23 neutrons and it is 20 neutrons. So X has 3 more neutrons. In which ionic compound do all the ions have the same electronic configuration? Okay, so beryllium sulfide, I don't think, because beryllium is going to lose 2 electrons and sulfur is going to gain 2 electrons. Sulfur in its last shell has 8. Beryllium in its last shell has 2. Lithium fluoride. Lithium again going to lose 1. And it's going to have 2 electrons in its last shell. Magnesium chloride. Yeah. Yeah or not? In which compounds do all have the... No. Though the last shell electronic configuration of magnesium and chlorine is going to be 8 and 8, but the full electronic configuration is going to be different. Sodium oxide, yeah, that's correct. It's going to be 2,8 for sodium and it's going to be 2,8 for oxygen as well. But for magnesium chloride, it's going to be 2,8 for magnesium and it's going to be 2,8,8 for chlorine. Which ion has a positive charge? Ammonium. NH4+. Which was correct? The structure and bonding of hydrogen fluoride. Simple molecular. HCl. Hydrogen making covalent bond with chlorine. Structure and bonding of diamond. Giant covalent. Simple diamond, graphite, silica or giant covalent structures. Powdered calcium carbonate reacts with HCl to produce CaCl2, water and carbon dioxide. What is the correct ionic equation including state symbols for this reaction? Just seeing it, I think option A is incorrect because of a small reason. We're looking for ionic equation. That's the problem. Option A doesn't show the ionic equation because you know that HCl is going to be soluble, so it's going to form H plus signs and Cl negative ions, and then calcium chloride is also going to be soluble, so it's going to form Ca2 plus and Cl negative ions, and Cl negative ions are going to be same on the both sides, so it's going to cut out. So that's why option A is incorrect. Option B is correct. That's the ionic equation. Option C is again incorrect because of the reason that calcium carbonate is not going to dissociate. Over there, they've shown that calcium and carbonate decomposes. No. When you have something that's insoluble, it doesn't decompose. And the last one, again, doesn't make much sense because of the reason that calcium carbonate has to be shown like a solid because it doesn't decompose. Which structure shows the carboxylic acid with the lowest relative molecular mass? So this is not a carboxylic acid. this and this. This is not a carboxylic acid. This is a functional group that's called aldehyde, and that's not in our syllabus. So this is not a carboxylic acid, and this is ethanoic acid, and this is methanoic acid. So obviously we know that methanoic acid is going to have a lower molecular mass than ethanoic acid. A mixture of 2 grams of hydrogen and 32 grams of oxygen occupies a volume V measured at RTP. The gases react until there is no further change. So we have 2 grams of hydrogen and 32 grams of oxygen occupies a volume V. The gases react until there is no further change. So we know, according to the theory, 44 gram is going to react with 32 gram. So over here 2 gram is only going to react with 16 gram, remember? And how much water are we going to form? We're going to form 18 grams water out of it, because we're not going to form, like, I just halved the equation. That's the thing. Which reactant is in excess? Oxygen is in excess, because you know that according to the theory, we know that this is 2, this is 2. 2 times 2, that's means 4 grams. So 4 grams is going to react with 32 grams. 32 grams is the molecular mass of oxygen, and that's going to form 2 times 18. 18 is the MR of water, and we have 2 waters being formed over here, so that's going to be 36 grams, I think. So that's the perfect equation. But over here, unfortunately, we have 2 grams of this, 32 grams of this. So if we have half this, we have to half the entire equation. So 2 grams is going to react with 16 grams and 18 grams. So the reactant that's in excess is oxygen, because 16 gram oxygen is in excess. We're not using out of 32, we're only using 16. Final volume. Which reactant is in excess, and what is the final volume of the mixture at RTP? We have firstly it's V, and V has a volume of 2 plus 1. It has a volume of 3, but now only 1 is left. It has a volume of 2 moles of 1 mole of this and 1 mole of this. It has a volume of 2 moles. 2 moles volume, but now only half mole gas is left. 2 को अगर मैंने 1/2 पे लेके जाना तो I divided by 4. So option C. मैं आपको समझाती हूँ ये. What happened over here was कि I had initially 2 grams of hydrogen. 2 grams of hydrogen means I have 1 mole of hydrogen. 32 grams of oxygen means I have 1 mole of oxygen. That means in total I had 2 moles of my gases. But after the reaction was complete, I only have 16 grams of oxygen. 16 grams of oxygen means I have half mole of gases. That means initially I had 2 moles of gases, and now I have half moles of gases. So how do you go from 2 to half? You divide 2 by 4. That is 2. 1 times 2, 2 times. That is how you go to half from 2. So that's the thing over here. It's going to be option C. A chemist prepares calcium nitrate. They start with 8 grams of pure calcium oxide and an excess of dilute nitric acid. So he has 8 grams of pure calcium oxide and excess dilute nitric acid. They produce 12.65 grams of pure dry anhydrous calcium nitrate crystals. What is the percentage yield of calcium nitrate? It's fine, nothing to worry. We're going to make an equation which says that when we have calcium oxide and we make it react with nitric acid, which is in excess, what do we form? We form CaNO3, and since we have a base and an acid that's reacting together, so we're going to form salt plus water. So plus H2O. Okay? Now what do? We do a little bit of balancing by putting a 2 over here. Now remember one thing, that we know Kr, they produce 12.65 gram of pure dry anhydrous calcium nitrate. So this thing is going to be produced in 12.65 grams. if this is 12.65 grams and we calculate the MR of this thing, then we can calculate the moles of this thing, right? So but before calculating the moles, you have to realize one thing, that you had 8 gram of pure calcium oxide. So 8 gram of this is going to produce how many grams of this? Let's figure out. So if we do the mass ratio, we know that 1 mole of this is going to have a mass of 40 plus 16. So 1 mole is going to have a mass of 40 plus 16. 40 plus 16, that gives me 56. So 1 mole of calcium oxide ratio calcium nitrate, that's 56. That means 1 mole has a mass of 56 grams. 56 grams is going to give me calcium nitrate. 40 plus 14 plus 14 plus 16 plus 16, that all thing we have to do. 40 calcium nitrate, 14 plus 14 plus 16 times 6, that gives me 664. Oh, no. It was 40. 40 plus 14 plus 14 plus 16 times 6, that gives me 164. So 56 grams of this is going to make 164 grams of this. So if I have 8 grams of my calcium nitrate, then I'm going to produce X grams of calcium nitrate. Calcium nitrate comes out to be 8 times 164 upon 56 times 8 divided by 56, that gives me 23.4. So I should produce theoretically 23.4 grams. But how much am I producing? I am only producing 12.65. So basically this is the amount that should have formed, but the amount that formed was basically over here written 12.65. So 12.65 was formed divided by the total that should be formed, 23.4 into 100, and your answer comes out to be 54.0%. That's option A. The apparatus shown is used to investigate the electrolysis using inert electrodes of dilute sulfuric acid and concentrated aqueous sodium chloride in the separate experiments. Which row shows the ratio of the volume of gases collected in each test tube? Ratio of the volume of gases in X ratio Y. So this is test tube X, this is test tube Y, in dilute sulfuric acid. So first things first, you got to realize something, that when we're going to do the electrolysis of H2SO4, we're going to have two ions. We're going to have H plus ions and we're going to have SO4, two negative ions. And then for water, we're going to have, because we're doing of dilute sulfuric acid, so instead of like just sulfuric acid is water as well. So we have OH negative ions, and plus we have our very own H plus ions. So now what's going to discharge at the anode and at the cathode? Negative electrode is your cathode and positive electrode is your anode. So at the cathode, you're going to discharge your hydrogen ions. So H plus ions over here are going to be discharged. So we're going to form hydrogen gas. And at the cathode, what's going to be discharged is going to be your OH negative. At the anode, OH negative ions are going to be discharged and we're going to form oxygen gas. So when we're going to form hydrogen and when we're going to form oxygen, the ratio of the volume of gases is going to be very simple. So you got to think of like 4 OH negative discharge to form O2 plus 2H2O plus I guess 4 electrons. So over here 4 electrons are being lost, and when hydrogen is going to gain electrons, it's going to gain 2 hydrogens, going to gain 2 electrons to form H2. But over here we have 4 electrons that are being lost, so 4 should be gained. So we're going to multiply this equation by 2, and 4 hydrogen ions are going to gain 4 electrons to form 2 hydrogen molecules. So the ratio of hydrogen and oxygen is going to be 1:2. So ratio of volume of gas in X, what is X? X is your anode. At anode you have oxygen and at cathode you have hydrogen. So the ratios are quite simple. We have 2 moles of hydrogen and 1 mole of oxygen. So X ratio Y is going to be 1:2. And then now next we have to calculate when we have concentrated aqueous NaCl. So again, what's going to happen is that now we have concentrated NaCl. You have to remember, so now we're going to discharge chloride ion. So chloride ion is gonna form two chloride ions are gonna lose two electrons to form your chlorine gas. And now you have chlorine gas and you know two electrons are being lost. And now you write the equation for hydrogen. Two hydrogen ions are gonna gain two electrons to form H2. So over here you can say two electrons are being lost and two electrons are being gained. So the gain and loss of electrons is equal. Hence over here you can see it for yourself. The ratio of the gases at X and Y is gonna be 1:1. So does that make sense? I hope that should make sense. If you don't understand anything, just feel free to ask in the comments below. Which statement about the reaction is correct? A reaction in which the number of bonds broken equals the number of bonds formed always has an enthalpy change delta H equals to 0. Asha, now this might confuse some of you guys, but no worries at all. I tell you that you have E bond A bond E, and now you're forming E bond E plus A. No. Plus A over here. So over here, the bonds you're breaking is EA bond and AE bond. But the bonds you're forming is EE bond and EA bond. In total, you're breaking two bonds and you're forming two bonds. But the problem is that there's a difference. The enthalpy change for this reaction cannot be 0. Why cannot it be 0? Because the bonds that you're breaking and the bonds you're forming are not of the same time. You're breaking EA but forming EE. You get it? What's happening over here? So it is not the number of bonds that matter. It's the type of bonds. Okay? So that's why option A doesn't make sense. Combustion can either be exothermic or endothermic. Combustion is always exothermic because it always releases heat energy. In exothermic reactions, reactions that are going to release heat energy, thermal energy is transferred to the surrounding, so the temperature of the surrounding increases. Yeah, that's correct. If you have an exothermic reaction, what's going to happen? The temperature of the surrounding is going to increase, and if you have endo, it's going to decrease. The activation energy for the reaction is the minimum energy the particles must have in order to collide, in order to react. They're going to collide even if they don't have the activation energy. The particles are still gonna collide with each other, like boom, 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 boom. But what's gonna happen? The product is not gonna be formed because the collision is not gonna be enough powerful. So over here, I tried solving question number 13. The word equation for the two reactions is shown. It was very simple. You just had to take ethene because they were long calculations, so I just didn't record it. And then you had to add hydrogen to it. You're gonna form ethane. What do? You first take all the energy that you're giving to it. That's gonna be over here, and then you subtract from it all the energy that's coming out when all these bonds are gonna be formed, and then you get a negative 125 as your answer. And the next thing that's gonna happen is that you have to find the enthalpy change of the second reaction. That's ethene plus bromine is 1,2-dibromoethane. So you take ethene plus bromine and you form 1,2-dibromoethane. You do the maths and you get negative 122. Now the trick part in this question was, what is the value of delta H1 minus delta H2? So delta H1 was negative 125. So negative 125 and then minus and then delta H2, which was negative 122. So you just don't have to forget the minus sign. That was the trick part over here, which give us negative 125 plus 122. That comes out to be negative 3, which makes option C the correct answer. Two changes are described. Change 1 states copper is added to concentrated nitric acid, nitrogen dioxide is produced. Concentrated sulfuric acid is added to sugar. The change that occurs cannot be reversed. So if it cannot be reversed, then that means we're dealing with a chemical change over here. And statement 1 is also chemical change. Not a chemical change, it's a physical change. Why is change 1? Because copper is added to nitric acid and then we are forming nitrogen dioxide. And the reaction can be reversed because you know that copper is less reactive than hydrogen, so it cannot basically kind of displace hydrogen. So that's why. And concentrated sulfuric acid is added to sugar, the change cannot be reversed. So that's gonna be a chemical change, because you know that chemical changes cannot be reversed, right? So that's the key over here. You need to realize that physical changes are reversible, whereas chemical changes are irreversible. That's a new thing that's been added to the syllabus, and I hope examiner test is going to test this. Which change increases the rate of a chemical reaction? Using larger pieces, no. Using more dilute, no. Using a lower temperature, no. Using a higher pressure, yeah, that's correct. Because when you increase the pressure, what do? You intentionally move the particles closer together, so they're going to react like faster. In two separate experiments, 1 and 2, an excess of powdered calcium carbonate reacts in a flask with dilute hydrochloric acid. So in two separate experiments, which is experiment 1 and 2, an excess of powdered calcium carbonate reacts in a flask with HCl. In experiment 1, the volume of carbon dioxide evolved is measured at regular time intervals. In experiment 2, the mass of the flask and its contents is measured at regular time intervals. The results of both experiments are plotted on the graph. So for experiment 1, amount of carbon dioxide increased, and the W, what is W and X? Which graphs show the results of these two experiments? Experiment 1. Obviously, the carbon dioxide is going to increase, so it's going to be W. And the mass of the flask is going to decrease, but it's not going to become 0. Why is it not going to become 0? Because look at the equation. When we make calcium carbonate react with HCl, we form CaCl2 plus carbon dioxide plus H2O. And this carbon dioxide gas is going to be released from the flask. Okay, the carbon dioxide gas is going to be released from the flask. But this water and CaCl2 is going to remain in the flask. So over here, experiment 2 is going to be Y. Fairly easy. Which statements about the Haber's process for the manufacture of ammonia are correct? At equilibrium, the concentration of the reactants and products are no longer changing. Yeah, that's correct, because they become constant. Increasing the pressure moves the position of the equilibrium to the right. So if to make an equation, we know that N2 plus 3H2 is going to form 2NH3. Okay, so over here we have 3 plus 1, we have 4 moles on this side, and we have 2 moles on this side. So increasing the pressure, when we're going to increase the pressure, the equilibrium move towards the side that has less moles. So it's gonna indeed shift towards the right. Increasing the temperature moves the position of the equilibrium to the left. No, we know that Haber's process is an exothermic reaction. And since Haber's process is an exothermic reaction, so increasing the temperature moves the position of the equilibrium to the left, not to the right. Okay, that's correct. So since it's an exothermic reaction, so the equilibrium is going to move towards the left, because heat is going to be released, and in order to compensate for that, equilibrium is going to do the endothermic reaction. So 1, 2, and 3. Acidified aqueous potassium manganate is used as a test reagent. When it is added to an aqueous solution of compound M, the color of the test reagent changes from dash. The color change shows that M is test for KMNO4 is used to test for KMNO4 is used to test for reducing agents. So what is a reducing agent? A reducing agent is a species that itself gets oxidized. So M is going to be oxidized, and the color changes from purple to colorless. Hopes that makes sense, right? Because potassium iodide is used to test for oxidizing agent, and KMNO4 is used to test for reducing agents. In a neutralization reaction, which change in the particles occur? Ions to molecules. How do I know this? Because in a neutralization reaction, the equation is H plus plus OH negative forms H2O. These are two ions, and H2O is a water molecule. Which pair of substances are both insoluble? Ammonium chloride, no. All ammonium salt soluble. Copper carbonate, yes. Copper hydroxide, yes. Because you know all carbonates are insoluble, and the hydroxide of the transition metals are also insoluble. Lead nitrate soluble, zinc sulfate soluble. The atomic number of the element X is 12, so we know that 12 is gonna be magnesium, definitely, because magnesium has in the product table atomic number 12. What is the formula of the chloride of X? XCl2, because you know MgCl2, because Mg is gonna form a charge of 2 positive and Cl of negative 1, so it becomes MgCl2. Element P, Q, R, S are either in group 1 or group 7. P is a liquid at RTP, Q is a gas at RTP. We know what is P. You know what is P. P is going to be bromine, because the only element in entire group 1 and group 5, 6, 7 that is a liquid is bromine. Q is a gas. If Q is a gas, okay, is P, Q, R, S are either gas. You know, no group 1 is going to be a gas. So Q is also going to be either it can be fluorine or it can be chlorine. Element R and S both form basic oxide. R and S are going to be in group 1. Element R has higher melting point than element S. That means R is above S in the group. Which pair of elements give the most vigorous reaction? S is below S and Q. S and Q. Where is S and Q written? Because fluorine or chlorine, and then S is because down the group 1 the reactivity down the group reactivity is gonna increase, so S is gonna be more reactive, okay? And then over here we know that in the halogens the upper elements are more reactive. 3 statements about noble gas are listed. Their atoms all have 8 electrons in the outer shell. Their atoms all have no. Helium does not has 8 electrons. They are unreactive because the outer shell is full. They're diatomic. No, they're monatomic. So 2 only. Makes sense? Solid 1 and solid 2 are both elements. Solid 1 is not malleable, are both elements, not metals. Solid 2 is ductile, so solid 2 is a metal. 1 is maybe a non-metal. Which statement is correct? Solid 1 has good electrical conductivity when molten. No, it's an element, not an ionic compound. Ionic compounds are going to give, if they've written it's a compound, then we could consider it. But no, solid 2 has good electrical conductivity only when molten. No, not only when molten, even in solid, because it's a metal. Metals have good conductivity both. The layers of ions in solid 1, they're not going to be layers of ions, because solid 1 we're considering to be a non-metal. The layers of ions in solid 2 can slide over each other. Yeah, that's correct. And why can these layers slide over each other? You should know. Because we are dealing with a, what kind of substance are we dealing with? We're dealing with a metal, and we know that metal is going to form positive ions. And then we know one other thing as well in metals. There's going to be a sea of delocalized electrons that are going to be wandering here and there. So that's the metallic lattice. So over here we know that when we're going to apply force, the layers can slide. When a piece of aluminum is placed in cold dilute hydrochloric acid, no reaction is observed. What is the reason? Because aluminum has a layer of oxide that prevents it from getting to the metal. That's the only reason. Otherwise, aluminum is more reactive than hydrogen. It can definitely replace hydrogen from the hydrochloric acid, but the problem is the layer of aluminum. A piece of zinc is attached to a steel core to prevent it from rusting. Which statement is correct? Okay, so we have a steel core over here, and we have a zinc over here. So what are we doing? We're doing sacrificial protection. A piece of copper is more effective. No, copper is going to be worse. Copper is going to make steel rust more, because all the air and the water is going to react with the steel and nothing is going to react with the copper. A piece of magnesium is more effective than zinc because magnesium is less reactive than zinc because it's more reactive. A piece of zinc provides a barrier. No, it's not. It does not provide a barrier. A barrier means that you have a layer on the top. So if I put a layer like this of zinc, that's going to be a barrier. It just provides a sacrificial protection, and that's all. Okay, no worries. Which statement about the extraction of iron from hematite in the blast furnace is correct? Coke is reduced to carbon dioxide. It's oxidized. Carbon forming carbon dioxide, oxidation. Hematite contains iron 3 oxide, which is reduced by carbon monoxide. Yeah, that makes sense. Hematite is Fe2O3. It's reduced. It loses its oxygen to form Fe only by carbon monoxide, and carbon monoxide is oxidized to form carbon dioxide. Limestone is added to the blast furnace, and the substance consists mainly of calcium and its substance and is a substance. Limestone is added to the it's calcium carbonate, not calcium oxide. It decomposes to form calcium oxide. Molten slag is formed from the reaction between hematite and silicon IV oxide. No, I don't know what kind of thing they write between silicon IV oxide and your calcium oxide. Water may contain many substances before it is purified for drinking. 3 substances are listed: dissolved oxygen, harmful microbes, insoluble solid. Which substances are removed by the treatment of domestic water supply? Dissolved oxygen, I don't think you can remove. Insoluble solids, yes, you can do sedimentation and filtration. And then the next thing is harmful microbes. You can add chlorine to kill them. But dissolved oxygen, you cannot do anything to take out oxygen out of water. So 2 and 3. Dry air is a mixture of gases. 99% of the mixture is nitrogen and oxygen. What is the main highest of the 1% carbon? Argon. Thank God I remember it. Argon and then carbon dioxide. Okay? So please don't forget this thing that you have argon and then carbon dioxide. So argon forms 0.9% and carbon dioxide about 0.04%. So that's a smaller number. Which statement about alkanes is correct? Ethane reacts with chlorine in an addition reaction. In a substitution reaction, propane has a higher boiling point than butane. No, butane is higher because it has more number of carbon. The molecule of alkane that contain 99 carbon atoms contain 2 hydrogen atoms. There are 3 isomers with the formula C4H10. So in alkane that's at 99. So if we use the general formula, that's CnH2n plus 2. So 2 times 99. Let's see, what do we get? 2 times 99 plus 2. Yeah, we are getting 200. So that makes option C the correct. Thank God we don't have to make isomers. Okay, compound X is an alcohol containing only 3 carbon atoms. That means we're dealing with propanol. Compound Y is an alcohol containing 4. We're dealing with butanol. Both compounds have general formula this, which shows the number of structural isomers of compound X and Y that are unbranched. Propan 1-ol, propan 2-ol, butan 1-ol, and butan 2-ol. Simple as I can tell. You don't make any branches. What you do is you put the OH on the first carbon, that's propan 1-ol. You put the OH on the second carbon, that's propan 2-ol. Then what do? You put the OH on the first carbon, that's butan 1-ol. You put the OH on the second carbon, that's butan 2-ol. Simple. Which 2 compounds react to form this? So first, what do? We break it from the middle. This part is the acid part. How do I know it? Because it has a carbon oxygen. That's the acid. You might think that this also has a carbon oxygen. But the trick is that this carbon oxygen, this carbon is bonded to 3H. But the acid carbon is only going to be bonded to this O, not any H. Okay, so the acid contains 1, 2, 3 carbon atoms. Acid contains 3 carbon atoms. So that's our very own propanoic acid. And then we have a methanol. Propanoic acid plus methanol. Fairly easy. 3 statements about fuels are listed. Fossil fuels include coal, natural gas, and wood. Petroleum is a mixture of hydrocarbons. Naphtha is used as a chemical feedstock. Wood is not a fossil fuel, right? Wood, because fossil fuels are those that are non-renewable, but wood is renewable. You can get it again and again by planting crops. But coal and natural gas are not going to come after just 2 days. They're going to come after millions of years. Which statement about propene is correct? Propene is saturated, not unsaturated, it's ene. Propene is the 3rd member of alkenes, yeah. No. I just fell into the trap. It's the 2nd member because we don't have any methane. Remember, the examiner is trying to trick us. So it's the 2nd member. Propene reacts with bromine in a substitution reaction known as addition. Because it's an alkene, it's going to give addition with bromine. Propene reacts with hydrogen in the presence of nickel catalyst to produce propane. Yeah. In a alkene, you add hydrogen, it's going to get saturated and going to form an alkane. Copper 2 oxide reacts with dilute ethanoic acid. Which equation is correct? So we have an oxide, and then we have an acid. How can we form hydrogen? That's base plus acid. So we're not gonna form hydrogen, so cross and cross. And since we know copper has a charge of 2 plus, so we need a 2 over here because we know one ethanoate ion has of -1. So we need a 2 over here to balance this copper. Okay. The diagram shows the repeat unit of a polymer. Which row shows the monomer and the type of polymerization? It's simply, we can see it's addition polymerization. And the monomer is going to be this. C2 is simple. You just put the bonds inside. There is no rocket science in it at all. It becomes C double bond C, H, 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 C2H5. Done. Okay. A piece of apparatus is used to measure the volume of the acid required to neutralize 25 cm cube of alkali in a titration. Okay, which piece of apparatus? Okay, so that's going to be a volumetric pipette because you have a exact volume. A mixture contains two solids, X and Y, and no other substances. So we only have a mixture contains only X and Y and no other substances. X and Y are both soluble in water, so we can add H2O, which is water in it. The student separates X and Y using two steps. Step 1, the student stirs the mixture into a beaker of cold water. What is step 2? So both are soluble in water. Both have dissolved in water. Now you cannot use chromatography, bro. You know why you cannot use distillation over here? Sorry, not chromatography. You cannot use distillation over here because both are soluble. What's going to happen is that in distillation, all your water is going to be distilled over and your salt are going to be left behind. So to separate the two soluble substances, we're going to use chromatography here. Crystallization is going to make crystals of both. We got to separate. Filtration, obviously both have dissolved, so only chromatography is going to be used here. Solid J contains cations and chloride ions. The aqueous solution of J is colored as two separate samples of solutions are tested. Aqueous sodium hydroxide added to the first sample produces a white PPT. Aqueous ammonia added produces a white PPT. Which statement about J is correct? The cation in J must be aluminum 3+. The cation in J must be Fe2+. White PPT Fe2+. Doesn't make any sense. It must be aluminum because zinc also produces white PPT with both. We're not given with the solubilities. When dilute nitric acid and then aqueous barium nitrate is added, a white precipitate is formed. No, we're dealing with chloride ions here. In chloride, we don't add barium nitrate, we add AgNO3. When dilute nitric acid and then aqueous silver nitrate are added to a solution, a white PPT formed. Yeah, that's the test for chloride ions. Simple. Solid Q reacts with HCl, producing a gas that turns lime water milky. Okay, we have a solid that's reacting with HCl to produce carbon dioxide. So the solid is going to be a carbonate for sure. Warming solid Q with aqueous sodium hydroxide produces a gas that turns damp red litmus paper blue. Test for ammonium ion. Simple. If you don't believe it, learn for the test for cations and anions, and that's all for today.